everyone, and thank you for tuning in to the ideaXme podcast, where we're moving the human story forward. 2019 has turned out to be a very busy year in space news. NASA has formally announced the Artemis mission, where they plan to return and land on the moon by 2024. Meanwhile, private companies are advancing technologies and capabilities to make lower Earth orbit more accessible to commercial industries, space travelers, and scientists. Today I visited Nanoracks here in the Houston area to check out their latest projects and how they continue to facilitate access to the International Space Station for scientific research. This and more fun topics are discussed in my interview with their Chief Innovation Officer, Mike Lewis. Take a listen. Thank you, Mike, for sitting down with me today to chat about all the amazing things that Nanoracks is up to. Please tell our audience, who are you?
Well, first off, thank you, Anna. I appreciate the opportunity. My name is Mike Lewis. I'm what's called a Chief Innovation Officer at Nanoracks. Nanoracks is a interesting company. We truly are a commercial aerospace company. We specialize in putting things on the space station, science, research, education payloads on the space station. So I'm the guy that gets to figure out how to make it happen. We have a lot of big thinkers around here at Nanoracks, and I get to be the person that determines if it's feasible or not, and how we're going to make it happen.
So I've heard you all being referred to as the UPS to the space station, or like the concierge to the stars. Yeah. Can you go a little bit into detail as to why you're called that?
Yeah. Well, we're called that because we have a bit of an identity crisis. We have about 30 different mottos, but it actually is it's a good example of kind of the diversity of the company, I guess. Yeah, so we've been called the UPS or the FedEx or the DHL of space, because we kind of act as the go-between between people that are performing science and the difficult system that exists around NASA to get things into space. Kind of a bit of background. So back, early 2000s, they were nearing completion of the space station, and NASA had been in full construction mode. The shuttle was going up all the time. They're building new parts of the space station. They're reconfiguring all kinds of things, and in early 2000s they said, "Uh-oh, what are we going to do next? We're almost done." And they got together and said, "Well, okay, let's designate this a national lab." So the space station, which has been it's been inhabited, every day there's been a person in space since 2001, is this magnificent machine in space. It's about the size of a normal house, the living volume, but it expands to the size of a football field, and it's this big, incredible place to do science. And so NASA said, okay, well, we want to open this up. We want people to use this. So the U.S. part was designated this national lab, and they said, who wants to use it? And so Nanoracks, one of the first people, stick their hands up and said, we want to use it. And the way you do that is you sign up for something called a Space Act Agreement. And then that one document gives you the ability to use the space station. And it gives you access to all the the facilities that are up there. There's a lot of really unique science things up there. It gives you access to space on the rockets that are going up to the space station and coming back. And then it also gives you access to the astronauts, the crew. You can ask them to do things for you up there. So we signed up for that, took advantage of that, and not really knowing what we were doing. We realized we were pioneering new ground, and so we signed up. We started advertising that we could get your experiment to space, and it started happening. People started coming to us.
So you have a dedicated area or rack space on the space station. Where do you put these experiments, and how how do they get out into space, and and you deploy them and all that.
So at first we flew a small experiment. It fits in a locker. Mm-hmm. Basically, the space station has a bunch of racks on it, and then these locker things are about the size of a microwave. Mm-hmm. And we asked for one, and they gave us one of these spaces. And so that we flew basically a computer. Mm-hmm. We made it fancy and space rated by you add certain power control things, and there's electromagnetic interference considerations and things like that. But for all intents and purposes, we just flew a computer that fits in that locker. Mm-hmm. And that we still have 3 of those on orbit. Those computers, they kind of enable us to plug in other experiments. Mm-hmm. So people can come to us with an experiment, and we'll fly it up there. It plugs in just like a USB device would plug in it, on your home laptop, and then we remote desktop into it and control it from the ground.
Wow.
So we have that. Then there's this other aspect where, because of the Space Act agreement I was talking about, there's a lot of other facilities up there that do unique things, that do really complicated things, and we're able to use those things as well. We have to coordinate that with NASA, but we do.
So I understand then concierge, because you guys are basically taking care of the daunting task of dealing with the bureaucracy of NASA. Right. Everything from manifesting and reserving space in a rocket or a capsule to get things to the space station, as well as scheduling time with crew for the astronauts to be able to work with the experiments, and also the engineering of putting these racks together, or these lockers, making them fit in the lockers and everything. Right. So basically you're making it easy for people here on Earth to just transfer their experiment from one place to another, and they don't have to deal with the headache of everything in between.
That's right. Yeah, so anybody who's ever flown an experiment to space prior to Nanoracks, and prior to commercial aerospace really knew that it was a huge process. Mm-hmm. Even if you were really on top of things, it would take years to get an experiment up to space. Many people, you talk to them, they would spend their whole career and have one thing that flew, one experiment. And I guess, in contrast to that, at Nanoracks we've flown 800 payloads. So we've streamlined this.
Oh wow! So since you opened your doors in 2009, you've
800 payloads plus. Yeah.
Wow.
So it's nuts. And, anybody who's been in the Nanoracks facility knows we have so much spaceflight hardware lying around. It's amazing. It brings up an interesting point. We actually exist as a company because that process is difficult. Mm-hmm. It's difficult to get through the NASA gates. Mm-hmm. It's a bureaucracy in many ways, and there's a lot of difficulties with verification, safety, all these just coordination things, and it's very often it's knowing who the right person is at NASA to go to, right, to coordinate that. And as somebody who just is researching, I don't know, slime molds, you don't know where to start there.
Yeah.
So in a very good way, we exist because the NASA system is difficult.
Yeah. Yeah, it's a special niche for sure. So who is your typical customer?
Typical customer could be anybody, really.
Yeah.
That's the whole goal, is anybody who's got good reason to be in space, we can make happen. The majority of our customers to date have been researchers, folks that are either doing research inside the space station, which is called IVA, intervehicular activity, or things outside. There's a number of things, including the Nanoracks external platform, where you can mount things outside the space station. Then also outside are satellites. And of those 800 payloads, over 230 have been satellite deployments. So a big part of our customer base are people that are researching space, either observing the Earth or observing some aspect about space in in one of those forms.
Speaking about the exterior of the space station, I understand you guys have an airlock that's flying soon that will be connected to the space station. It's going to give you another capability to get these CubeSats out.
Yeah.
Tell me a little bit about that.
The Bishop Airlock is exciting. We didn't really know what we were setting out to do when we when we said we were going to build the airlock. It's funny how I'm sure there's a life lesson in this, and I'll get to it. But we've always just kind of kept pushing forward, right? And we said, okay, well, we're going to keep saying yes. We're going to keep doing things. We started flying experiments inside the space station, which led to us building slightly bigger experiment modules on the station. We said yes to satellite deployment, which led to our other bigger satellite deployers, which use the computers, which we're going to use on the airlock. We built a satellite deployer that goes on the outside of a space of the Cygnus spaceship, and that gave us the credibility to build structures that would be man-rated and survive in space. So it's one of these, we just kept moving, kept going, kept innovating, doing new things, and it led to this building the first truly commercial element of the space station, there at the Bishop Airlock. So this thing is nuts. It's for us, a company that has the word nano in its name. This is a big thing.
Yeah.
It's about as tall as a person, actually a little bigger, and it holds about 4.5 times more than the current airlock capabilities on the space station. So on the Japanese module, there's an airlock that allows things to go in and outside, and very small things, not for people. There's a specialized airlock, different location for people, but this is just for experiments. And the Japanese one, it's a wonderful facility, and allows things to go outside, things like our satellite deployers, our external platforms, a lot of things like that. But it's restrictive in that it's kind of small. The biggest thing we've put out there is about the size of a filing cabinet or like a dorm fridge, like a kind of small thing. This airlock is going to allow us to put out things that are just significantly bigger. And it's important for a couple different applications. For one, we can deploy satellites out of it, and we can deploy a whole lot of satellites. We could deploy a constellation of satellites if we needed to. It also has increased the external real estate. There's 6 different locations that have a oceaneering gold connector, they're called, but this a spot to attach payloads on the outside, and they get power and data, and we're able to control them like our frame computers. Other part that's really kind of surprising about this is that as we have been building this, we've had a lot of people come to us from NASA, but also from ESA and private investigators with their own unique applications. One of the ones I really like is they're looking at using the airlock for trash disposal, which is pretty awesome, actually. You never think about this, but you've got up to 6 people in the space station living, eating, creating waste.
Yeah.
And you have to get rid of it.
Yeah.
And the way they get rid of it now is they stuff the Cygnus vehicle full of it, or the HTV. SpaceX's capsule returns with a lot of return science and things, but it's also every little nook and cranny is full of trash. So if you can get rid of that some other way.
Yeah, I've heard if it takes too long, you can start smelling a little bit of it in the space station.
So this is a sidebar, but this is kind of a funny story. So there's an astronaut named Don Pettit, and he's famous for pocket science and just wonderful things. I urge the listeners to Google him.
He has a lot of videos on YouTube.
So he's fantastic, and when he was up there, we had a couple things. We had we had our frames and things like that, but we had a microscope, and that was his favorite toy apparently. He used
That's not surprising.
He used that microscope so much, and Anyway, he broke the microscope. That's all another story. But we have a microscope up there now, and I forgive him. But he came back down, and he was over here at our facilities, and he was just kind of telling us about his whole experience and everything. And that day, we happened to get a return shipment of stuff that had been in space, been on the space station, and had been returned. Mm-hmm. And we opened the back doors and we rolled it in, and when stuff comes back from space, it's all wrapped up in this pink plastic, and they make it airtight. Mm-hmm. And as we cut it to open it, it smelled awful. Don runs over, sticks his nose in there, and goes, "Oh, it smells like space." Smells like a locker room or 1,000 feet or so. It was awful.
Yeah, that sounds like Pettit.
But it was amazing. Just it reminds me of home. Yeah.
So the Bishop airlock is big enough for an astronaut to float in and kind of set up all the CubeSats and then float back out and like close a hatch maybe, and then the airlock kind of gets picked up by the arm and put outside to deploy.
Yeah, exactly. Mm-hmm. So it's important to note our airlock isn't man-rated. So we're or I guess human-rated.
Yeah.
You're not allowed to put. You can't use it for a person to go inside and outside.
To habitate or
exactly.
Right. Mm-hmm.
It's purely for non-people things right now. Mm-hmm. The way it works is it's very similar to a bell jar vacuum chamber. So if you visualize just a cup with an open end, that open end mounts to the space station, and the space station has a hatch on the side. And so once it's mounted to the space station, they open that hatch from the inside, and it becomes part of the pressurized volume. Mm-hmm. Then to disconnect it, you do the opposite. You can load it up. Astronauts will load it up with whatever science payload or satellites or anything. Close the hatch, depressurize the airlock, and then the robotic arm, the big SSRMS, comes over and grabs it, and it'll move it around where it wants to go. Point it down and away to deploy satellites, or point it up to look at the stars. And then once it's done that, you reverse the process to reattach it.
That is pretty cool.
Yeah.
So another project you have, which is a little bit more fun and homey, I guess you could say, is you guys just built an oven to bake cookies in space.
Yeah.
Tell me a little bit about that, because and explain to people why that's a big deal as far as engineering goes, in comparison to like an oven you would use here on Earth.
So the Zero-G kitchen oven is it has a special place in my heart. This is really a fun payload, and you're right. It started with one of our counterparts, a partner from Nanoracks, came and said, "Hey, how do they cook food on the station?" And I had to think about it for a bit. I knew about astronaut ice cream, of course. The dehydrated that stuff. And I just figured MREs and things like that. And turns out I wasn't that far off. For the most part, with some exceptions, Rachel Ray's made meals, Emerald Lagasse's made meals, but for the most part, they're heating up stuff with hot water, reconstituting stuff. And so I looked at that and said, well, gosh, is there any way to like bake? And it seems like such a simple thing, but when you get into it, it's difficult.
Yeah, zero-G gravity, right?
Right. You don't have... So one of the really interesting things about microgravity is that you don't have natural convection. So naturally on Earth, hot air rises, cool air comes down. And so in an oven, you have this natural motion of air. Now, if you put that same oven in space, you're going to get the top being hot and the bottom being cold, and you're going to have a gradient. And you're only going to get heat transfer through conduction and radiation. So baking something is actually kind of difficult.
Yeah.
So we set out to build an oven. We said, this has a lot of good purposes. For one, if we're going to spend years in space, if we're going to do long duration space travel to Mars and beyond, we're going to need a way to cook. It's such an important part of our psychology. It's just a part of our society.
Certainly, yes.
And we're going to need, these elements of home like that.
Yeah.
So we looked at building this oven, and at first I had some of the guys in the back just put together this really goofy little model, and we're actually reliving this story recently.
Mm-hmm.
For the installation. So they made a very small oven. So this was about a 10 centimeter cube oven originally. Mm-hmm. It's since grown, but they used can koozies as the insulation. And,
that sounds dangerous.
It was a proof of concept. I'm like, okay, that's all right. But it worked, and they ran with it. And it kept working and working. And Zach, one of the guys in the back, goes, well, I'm going to take it upon myself to cook a cookie.
Yeah.
And he baked it, and he baked a cookie. And we're like, oh, goodness gracious. And
I heard there was a lot of taste testing going on.
So
some of it was good and some wasn't.
This was the first very unsuccessful taste test. Turns out, don't use canned koozies if you're gonna eat whatever you bake. Poor Zach nearly poisoned himself, and
because of the foam.
Yeah. So we learned a lesson that day. Rest assured, the oven that we just flew on SpaceX 18 was it uses proper food grade materials, and it's able to.
So it already flew, and it's on space station right now.
It hasn't been installed yet, though.
Yeah. So what was the expected date of?
Oh, we should have that running in a couple months.
I see you have partnered with DoubleTree Hilton, and there's a little bit of looking into the future about this, because it's also looking into commercial travel. Yeah. In space for regular people.
It's a big honor to work with a company like DoubleTree, and they're part of the Hilton family, and I've found that just as we're experts in commercial aerospace, they are absolute experts in seeing the future of tourism and habitability and things like that. Mm-hmm. And they have been a great partner in this. In our cookie experiment, the first experiment that we cooked in the oven is a DoubleTree cookie. Mm-hmm. And I see them being leaders in those areas. Mm-hmm. NASA recently has made the announcement that you can, as a private citizen, you can buy a seat to space, and you can fly stuff now. You can just pay to fly things to space. And I think that's going to change the landscape, and we're going to see these kind of visionary companies like DoubleTree and Hilton come in and apply what they have succeeded at on Earth to just another place.
So putting together what you said earlier, you guys keep on looking forward and trying new things and expanding, and the landscape, how it's changing. What's in the horizon for Nanoracks? Are you guys planning to partake in maybe building another space station, or maybe partaking in the moon missions or Mars missions?
Absolutely. Yes. So to take a step back, we've always had a lot of support from NASA, and it's been excellent. NASA's wanted us to succeed so much that we create an environment that allows for competitors for us. And we've seen that, and we love it. It's great. It keeps us from just doing the same thing over and over again, and it creates this commercial ecosystem.
Well, it seems like eventually there's going to be plenty of work for everybody. Right.
And rising tide raises all boats. We want everybody to be very successful. But for us, that's had a unintended good effect, that it really keeps us motivated to look towards what is next. And you're right on. We want to not only use what's there now, but we want to use what's gonna be there. Just as we're a FedEx or a UPS in a lot of ways, we're also kind of a real estate agent. Using what's there. So yes, definitely. We did a contract. We had a small contract with NASA to do an investigation on what the next steps are for space stations. And our concept, which was kind of unique, was to reuse some of the parts that already go up. Every time a rocket launches, there's an upper stage of that rocket that's already in orbit. And so our focus was on what can you do with that?
Well, that's certainly, that's like repurposing and also avoiding space debris.
Exactly.
Which is also a big problem that, we would have to deal with as well, right?
Yeah, exactly. Now, you nailed the word, repurposing. If you have things like that, what else can we use it for? The hard part is getting something up there.
Yeah.
Now let's figure out how to utilize it.
Well, that is also seems to be getting cheaper and cheaper as well, because the rocketry part of the business seems to be becoming more competitive and more innovative. So that'll make your job easier as well, right?
Yeah. Well, I guess don't be mistaken. Rockets are still pretty expensive.
Yes. Yeah.
But you're right. Companies like SpaceX in particular. But more recently, the small rocket providers like Rocket Labs and, up until recently, Vector, they've been really pushing the envelope of what a rocket can do, both in terms of efficiency and then efficiency of cost. SpaceX they have a wonderful model where they've taken in all the processes into their own company instead of outsourcing, and so they're able to control things from a manufacturing point of view and decrease their costs. And that every bit of that makes my life easier, because it makes the cost of getting something in space go down and more accessible.
Yeah.
So, there's you're absolutely right. In the small rocket providers, we're going to see a lot of other opportunities. These bigger, the Northrop Grummans and SpaceXs of the world are really doing some great stuff for us.
So, on the personal note, was it always a plan for you to work in aerospace, or did you haphazardly kind of
stumble upon it?
Yeah.
No, I think anybody who's in this industry knows it's rare to stumble across. You kind of have to go for it.
Yeah.
This is one of these you'll find in aerospace in general, there's a lot of passionate people, and I'm the same. I got bit by the space bug, I guess, when I was young. I'm from a little town in Silver City, New Mexico, southwest New Mexico, and at one point I went to elementary school that was named for Harrison Schmitt, the Apollo astronaut. And very young age, I was probably 7 or 8, I met him, and he was from that town, and he was the first scientist in space. He was a geologist, and it really left an impact. And actually, it was fun. He wrote me, a signed picture, and I still have it on my wall at home. To Michael in the future, blah blah blah. And I got that picture, and I convinced my mom to make a spacesuit for me, and I set up I staged a picture just exactly like his. We took it, and this is back in the day where you had to go to, Walgreens and print it out or mail it.
Yeah.
Out. Got it the same size, and I signed, to Harrison, "Don't worry, I got this covered," or something like that.
Oh, sweet.
I said the world's in good hands. Don't worry, and mailed that back to him. That was the start. Yeah. The end of that story is 18 years later, my mom ran into him and said, "Hey, you probably don't remember this, but my son sent you a picture." And he's like, "Oh yeah, I've had that on my desk for 18 years."
Oh, wow.
That's
a great story.
But him being a person and my realization that a person could be in space and could do that kind of stuff really struck me early, and it kind of stuck with me.
So this begs the question: if you get asked and the opportunity presents itself, will you fly in space?
Oh heck yeah! I'm a decent candidate. I guess I'm right in the right category. So now, if you ask me would I go to Mars, that's a different question.
Yeah.
Do I get to go on the first ship or like the 7th ship? There's a different answer. How about yourself? Would you go?
I'm not that brave. Maybe Leo.
Yeah.
Maybe Leo, but not Mars.
Yeah.
It's kind of hard when you have family and friends or spouses or children, to make that decision. So,
Well, and we interact with a lot of astronauts here at Nanoracks. We get a lot of folks that come through, and we're either training them or we're showing them stuff, and showing them the airlock or this kind of stuff, and you realize just the sacrifices that they make to be in that position, and it's humbling because they're sacrificing their time with their friends and family, and putting themselves at risk, really to do science for me.
Yeah.
They're doing me a favor. They're helping me grow a business. So it's humbling.
So besides Schmidt, is there any other role model or someone or hero or someone that you look up to that you would like to meet or would have loved to have met?
So in the industry, I'm in a pretty amazing position because I've gotten to meet my heroes, so to speak. I stood by the lower section of the New Shepard rocket that had landed and talked with Jeff Bezos and Tory Bruno. And we talked about Denver Broncos quarterbacks. but here's these icons of the industry, and holy cow, the Elons, the Robert Biglows, we get to interact with those folks. So aerospace wise, I'm checking a lot of boxes. I work with a visionary, Jeff Mamber, and I get to talk to him every day. So that's good in the industry. If I could talk to anybody, alive or dead kind of thing, anybody that was around before the 10th century would be interesting. Just to get an idea what life was like.
How life was.
Yeah. Or Winston Churchill, I bet that guy is just so cool.
Yeah.
Would have been so cool in person.
Yeah. So have you had the opportunity to mentor someone or inspire someone to get into aerospace or make decisions in their career that in relation to engineering, let's say?
I sure hope so. One of the big drives here at Nanoracks has always been every payload we fly has to have some sort of, pushing something forward. We're going to be learning something new in scientific field or educating people. And a big part of that education is one, we have experiments that are done by young kids. They're done at elementary school levels, things like that. Our mix sticks are done throughout the country and throughout the world, really. And not only do they get to do science that's applicable to their everyday life, but they get to realize that space is achievable and within reach. Personally, I really value the tours I get to give. We work closely with the NASA Hunch Group and a lot of other educational groups. And I really enjoy being able to communicate what I do. And
it never gets tiring to see kids when they see all the cool space stuff, the look in their eyes, and the jaws dropping, and it never gets old.
Absolutely. Well, and what I like is that I can be happy and excited about this stuff, and you can see that excitement come back on me, and it's almost like, hey, it's okay to be really pumped up about this cool stuff, guys, and that, that's a great feeling. I've had some interesting outcomes from otherwise tragic events.
Yeah.
There's a student that I met at this it was a conference in Colorado, and the student was one of many that flew a payload with us. They built this module that plugged into our computer frame up there, and we put it on the rocket. The rocket was Orb 3, which blew up about 300 feet in the air.
Oh, that was during the 1-year mission, right?
Yeah.
Yes.
So it took off and it blew up, and these poor kids had to watch their experiment that they had worked on blow up.
Heartbreaking.
So we said, guys, it's going to be okay. We're going to put you on another rocket. We're going to get you to space. It's going to be all right. So we did that and put their experiment on the next rocket, which was SpaceX 7, which also
had an anomaly. Yes.
So
that was a tough year.
I joke, gosh, we lost a Russian one as well. So I joked that experiment was made a lot of doctors, veterinarians, dentists, a lot of people a lot of students that were no longer going to be aerospace engineers.
Yeah.
But to my surprise, I ran into one of these students. She was a freshman at CU, and I was at the ISS, the Space Symposium in Colorado, and she's like, "Oh no! If anything, that made me like space more. Like the fact that you just have to be resilient and you have to keep going. It's like it. You always hear the term "space is hard."
Yes.
It's like that reinforced that for her. Like, well, of course I'm gonna do space because it's hard.
Yeah.
Yeah.
As long as you inspire at least one, it's a good day.
Yeah.
Yeah.
Oh, yeah.
Well, thanks a lot, Mike, for taking the time to sit down with me. I'm pretty sure our audience really will enjoy this interview. And we wish you and Nanoracks the best of luck, and we'll be watching as your future projects unfold.
Well, I sure appreciate the opportunity. Welcome all your listeners to follow us on all forms of social media, and check us out at nanoracks.com. Find us online. Thank you so much. It's been a real pleasure.
Thanks again for listening to my interview with Mike. For more information about Nanoracks and to follow them on social media, we have included links in the description of this podcast. Have a great day, everyone.